Hey everyone, welcome in. Thanks for joining. We're just about to get started. If you are looking for the geoengineering webinar, you're in the right place. And I'm going to hand it over to Mike to get us started.
Thank you, Nicole, and welcome everyone to this special webinar focused on global warming and new calls for research to explore ways to reflect sunlight away from the Earth as a possible cooling strategy. My name is Mike Tidwell, Executive Director of the Chesapeake Climate Action Network, and we are pleased to host this event for our supporters across the region and nationwide. Tonight, you'll hear from CCAN on why we believe this issue of solar geoengineering research deserves our attention and conditionally, and I emphasize conditionally, our support. No one on this webinar tonight is calling for deployment of any global system to engage in solar reflection methods or solar radiation modification, as it's known. We just want to begin the conversation and share our views. So tonight, you'll hear from me and my colleague, Quentin Scott, Federal Director of CCAN. You'll also hear from Dr. Greg Frost, climate scientist at the National Oceanic and Atmospheric Administration, about the limited research NOAA is undertaking presently. You'll also hear from our coalition partner, Suchi Talati of the Alliance for Just Deliberation on Solar Geoengineering. Then we'll take questions from all of you. This webinar is taking place as the wildfire tragedy in Los Angeles continues to unfold. Our hearts go out to the people caught in this climate-enhanced disaster and similar disasters happening worldwide from warming temperatures that are spiking now beyond some of our worst fears. These conditions set the table for the conversation tonight. To begin, I would like to play for you a 6-minute film that describes my own personal evolution and that of CCAN on the issue before us tonight. Here we go. As director of the Chesapeake Climate Action Network, I'll admit I've been peacefully arrested a dozen times for protesting fossil fuel companies. I've also led marches with thousands of people demanding wind and solar policies from state and federal lawmakers. And I'm a vegetarian because of global warming, and I power my house and my car with solar panels on my roof. In the climate movement, I'm as committed as they come. Many of my friends and colleagues, therefore, are now surprised when I tell them I fear we may have already lost the battle. The clean energy revolution, while fully underway and unstoppable, can no longer by itself save us from profound climate change. With alarming recent spikes in global temperatures and Donald Trump's return to the White House, we must heed scientists like Dr. James Hansen, who say we need to urgently research ways to reflect sunlight away from the planet. We need to think about a plan B, they say. The bullhorn-toting activist in me has resisted this idea for years. The concept of so-called geoengineering is not new, of course. The first major government study on global warming in 1965, under President Lyndon B. Johnson, recommended studying floating billions of white buoys across the world's oceans to reflect sunlight. And the 1991 eruption of Mount Pinatubo in the Philippines spewed so much light-reflecting sulfur dioxide into the stratosphere that it cooled the planet by a full degree Fahrenheit for more than a year. Could human beings safely disperse sulfur themselves using high-flying airplanes to become a quote-unquote human volcano? Hansen, our most famous and unnervingly accurate climate scientist and prophet for decades, says we should study it now as a possible option for future global leaders. We at CCAN have always believed that mass movement activism would eventually triumph totally over the dirty energy companies. The history of reform movements was on our side. So geoengineering? Seriously? Won't the carbon barons just keep burning their product and acidifying our oceans if we conveniently cool the planet for them through artificial means? And what of the sheer hubris of applying yet another techno fix to our endless energy and ecological problems? And what of the inevitable unintended consequences, large or small, of solar radiation modification, as it's called? All valid concerns, but several factors in recent years have flipped us towards supporting international research into light reflecting techniques. We don't support actual deployment of any such method at scale. Only a careful and inclusive international treaty can do that. But research? Yes. Our conversion, ironically, begins with optimism around clean energy. The renewable power revolution, again, is unstoppable. No American president or Congress can derail it, though, yes, they can slow it down. But key U.S. states and the rest of the world will continue moving forward with or without Donald Trump. Every day, a whopping gigawatt of solar power is installed worldwide. That's the equivalent of a new nuclear power plant daily. And next year, half of all cars sold in China, the world's largest automobile fleet, will be electric. And Australia will get 80% of its electricity from carbon-free sources by 2030. Simply put, as a planet, we're not going back, and the days of fossil fuels are numbered. But here's the problem. We started way too late. Because of delay and deception from the fossil fuel industry, the full global conversion to clean energy is still decades away, and there's enough CO2 already in the atmosphere and more on the way to cook the planet. Indeed, since 2014, United Nations scientists have been calling for massive amounts of quote-unquote negative emissions as a vital supplement to clean energy and stabilizing the climate. We need giant machines for sucking carbon dioxide out of the air at scale, they say, or rock weatherization techniques that crush stones like basalt and then they bind with carbon in the air. None of these technologies, however, are anywhere close to being ready to scale up. So if we're tardy on clean energy and carbon direct air capture is in its infancy, and the world is today about to surpass the 1.5 degrees Celsius level of warming scientists say is a threat to all living things, then what? For me, a final argument for geoengineering research lies right outside my own front door. From dying oak trees to widespread Lyme disease to unprecedented flooding, climate change is wreaking havoc in my small city of Tacoma Park, Maryland, bordering Washington, D.C. Among other extraordinary and expensive measures here, my town just built a $45,000 flood berm to keep newly torrential rain from entering our local church and preschool again. My neighborhood is a reasonable proxy for every community on earth, including yours, with poorer communities suffering the most while contributing the least to the problem. So what can we do? In June 2023, the White House Office on Science and Technology offered guidelines for policymakers and scientists considering research into ways to reflect sunlight from Earth. The paper states that there are risks to geoengineering that could be reduced through careful study and limited testing. There are also risks to doing nothing, letting runaway climate change take its course. Balancing those risks as best we can is a central challenge for the world of the 2020s, the paper suggests. Personally, as I look out my own front door and read the daily climate news from places like Los Angeles, I believe the danger of not researching a possible Plan B is likely greater than the harrowing climate path ahead of us, the one our movement has fought so hard to avoid. Okay, so welcome everyone again to this webinar, and I am now that you've seen some background on us, I'd like to hand it over to CCAN's Federal Director, Quentin Scott. Quentin's education, by the way, has involved studying math and science at Embry-Riddle Aeronautical University in Florida, but instead of becoming an engineer as a career, he's used his knowledge to build data-informed campaigns for political and environmental justice. Before joining CCAN, Quentin was chief of staff for an Illinois state representative and a legislative correspondent in the U.S. House of Representatives. Quentin.
Mike, thank you for that introduction. For the last 4 years at CCAN, I've been on the front lines fighting for the clean energy revolution. I made countless trips to West Virginia to persuade Joe Manchin to pass the Inflation Reduction Act. I've led rallies at the Environmental Protection Agency to implement historic rules to reduce carbon pollution from power plants. But in each of these cases, the full benefits of these recent victories won't be realized until well after 2035. And now I find myself on the front lines of trying to protect the most optimistic outcome we could have hoped for from hostile political forces. Meanwhile, the climate crisis is accelerating exponentially, independent of what is politically possible for our society to achieve. I sit in my office daily wondering what else can I do, wondering if it's time to think of a contingency plan, wondering if it's time to consider geoengineering research to answer the question, what is more risky, runaway climate change or solar geoengineering? For me, research became a yes last year. For myself, for Mike, and this organization, it was important for us to go into this work with our eyes wide open. So we created a statement of principles to guide our work, our decision making, to state clearly what we are for and what we are not for, more importantly. I'd like to share those principles with you tonight and walk you through the process we went through to establish these principles. First, Mike talked with CCAN's board. He laid out why he thought it was time to consider geoengineering research. The board asked difficult questions, raised concerns, and ultimately agreed with Mike's request to move forward with advocacy. Next, we discussed geoengineering research with CCAN's staff leadership team. Again, Mike and I laid out our reasons for supporting geoengineering research. I received tough questions and concerns from my fellow directors, but again, our leadership team signed off on research only. Then we had an all-staff meeting to listen to their questions, concerns, and feedback on how they felt we should move forward with this work. From the feedback from these 3 meetings, Mike and I drafted a statement of principles. We wanted to make sure every staff member was comfortable with the statement of principles, so we had hour-long meetings with small groups of staff with no more than 3 people. We wanted to make sure staff had ample time to ask their questions, provide additional principles, or suggest clarifying language to existing principles. As you can imagine, this was time-consuming to have all these different meetings, but that's how important the process was to us. We incorporated staff feedback and moved forward towards a final document. After staff meetings, Mike went back to the board to seek their final review of the statement of principles. At this time, I'd like to share my screen so you can take a look at exactly what the final principles look like and get a sense of how we intend to move forward with this work. So, I feel very confident that these principles clearly communicate to you on this call and to the public and to our partner organizations or whoever may ask what we stand for and what we don't stand for. The very first principle, as you can see, reaffirms our commitment to decarbonizing the global economy and continuing our mission as it has been for the last 23 years. Geoengineering research advocacy is an addition to our work, not a replacement for our decarbonizing efforts. We also support transparent, government-funded and led research and not research done by private in-the-shadow entities. We do not, and let me emphasize, do not support deployment of any geoengineering technique of any kind without consensus support from an international decision-making body that includes the voices of countries and peoples most vulnerable to and least responsible for the climate crisis. One last principle I would like to hone in on is our commitment not to support any geoengineering research or testing conducted by or for the benefit of any branch of the United States military or any nation's military anywhere in the world. Before I wrap up, I would like to point your attention to our website. As you can see, this page is not going to answer every question that you may have, but it's our goal to give you a starting place to take similar journey as we did towards embracing geoengineering research. First, we state our case for why research with links to articles demonstrating the new climate normal we're facing with intensified hurricanes, flooding, and heat waves. We share calls from scientists like Dr. James Hansen and others from across the world to rapidly increase research. And we also link to Biden administration's 2023 guidelines for conducting such research and testing. You will also find our statement of principles that I just went over. We also have a quick 2-minute video and an infographic going over the basics of solar geoengineering. We've also linked to a number of resources that we found helpful that when we made the decision to advocate for research. You'll also find works from our next two speakers, and we close out this page with a frequently asked question page. Again, I encourage you to explore this page and use it as a jumping off point for your own journey, similar to the journey that we've taken for the last 18 months. Now, I would like to introduce one of our next speakers, Dr. Gregory Frost, who is a NOAA scientist. He co-leads NOAA's research program with Dr. Victoria Breeze, and NOAA's program is called the Earth Radiation Budget Initiative, which is congressionally directed research program investigating natural and human activities that may alter the reflectivity of the atmosphere and impact the Earth system. He also serves as the user scientist for NOAA's Geostationary Extended Observation Missions Atmospheric Composition Instrument. He received his PhD in physical chemistry from the University of Colorado in 1995 and a Bachelor of Science in Chemistry from the University of California, Berkeley. Dr. Frost, tell us what's going on over at NOAA.
Sure thing, Quentin. Thank you very much for that nice introduction. I think you can see the slide deck there. Great. All right, so fantastic. Thank you so much for this opportunity. Both Victoria and I are very happy to be here. You can see our affiliations here, and Quentin did a nice job of introducing us. I did want to start by saying what we'll talk about tonight are our own views and opinions. They are not necessarily those of NOAA, the National Oceanic and Atmospheric Administration, or the U.S. Department of Commerce, to which NOAA belongs. So let me get rid of that little box there. Great. So I want to start our discussion tonight in the larger context of the ways that the world could respond to human-driven climate change. I think Mike set this up pretty well. And, I think you're all aware of the really increasing serious impacts of climate change. But the good news is that there are a number of tools in our climate toolbox, and many of those we've already heard about from the discussion we've already had this evening. So again, we can mitigate. The most important way to deal with climate change is to mitigate it by reducing our current and our future emissions of greenhouse gases. We can accomplish that by becoming more energy efficient, switching to renewable, non-fossil fuel energy sources, and even changing our diets. We can also adapt to the consequences of a warming world by tailoring the infrastructure that we build to meet new challenges like sea level rise or improving our city's capacity to shade people from extreme heat. And it's increasingly likely that we will have to remove legacy carbon that's already been emitted to the atmosphere in order to reduce the rise of temperatures. Now, all three of these climate tools, they're already on the table. They're all in various stages of development and implementation. However, there's a growing consensus of climate scientists that mitigation efforts are not scaling up fast enough to avoid the worst impacts of climate change in the future. And so a fourth potential response to climate change, solar radiation modification, that's SRM for short. It's also known as solar geoengineering or solar climate intervention. These methods have been proposed. Now, unlike those first three tools, the inclusion of SRM in the toolbox is not a given. So while SRM approaches have been talked about for many decades, as Mike pointed out, there's really been a really notable increase in interest over the last decade or so. The National Academies of Science, Engineering, and Medicine report that SRM approaches are really the only ways that we know of, at least right now, by which humans could potentially cool the Earth within a few years after deploying them. Of these SRM methods, the most talked about one is stratospheric aerosol injection. And what that involves is increasing the amount of small particles in the stratosphere. And these particles would reflect sunlight. And we know, as Mike already pointed out, that volcanic eruptions have done this many times in the past. And the reason that this works is because if these particles get in the stratosphere, they tend to stay there for months or even years. And they act like kind of a reflective film up there. And indeed, we have lots of scientific evidence that this does indeed cool the planet. Marine cloud brightening is kind of a second level, a second approach, and that involves taking sea spray particles in the ocean and injecting them into low-level marine clouds, and thereby increasing the reflectivity of those clouds. Again, there's a natural analog for this that we know is occurring. That the emission tracks, the plumes that come out of large ships can effectively do the same thing, and so we have evidence that they are that this is at least a possible way to cool the planet. And a third way is called cloud thinning, and the idea would be to reduce the thickness of clouds in the upper atmosphere to allow more heat to escape from Earth. This is the least understood of these three methods, and it's really considered a distant possibility. So why should we engage in SRM research? So the reason to think about SRM, of course, is when it's coupled with extensive mitigation measures, a well-designed SRM implementation could reduce climate hazards, and it could preserve critical ecosystems, and it would give time for the full implementation of mitigations while avoiding some of the most serious impacts of climate change. That's demonstrated with this kind of simple diagram here, which shows the possible futures of how global surface temperatures might change over the coming decades. The black curve represents a trajectory in which only limited mitigation measures are adopted, and you can think of that as really the worst case scenario. The orange curve represents the world adopting aggressive mitigation, and it's really the aim of international agreements that are trying to keep global temperatures below some agreed upon limit. Now, even with extensive mitigation, temperatures might pass agreed upon thresholds. And that happens because it takes time to scale up the mitigation, and there's a built-in inertia in the climate system. So it takes time for the climate system to respond. So SRM is thought of predominantly as a way to shave off those peak temperatures and give the world a little more time for necessary mitigations. Now, in fact, the current trajectory we're on in the world right now is somewhere in between that black and that orange curve. And there's a lot more that needs to be done to reduce greenhouse gas emissions in order to get closer to that orange line. And of course, there's mounting evidence now that the world is in the midst of crossing one of these temperature thresholds, 1.5 degrees Celsius above the global average surface temperatures that were experienced before the Industrial Revolution began. Now, of course, this diagram, it's a very idealized picture. The viability and the impacts of different forms of SRM, scenarios for how they might be deployed in combination with mitigation measures, all of that requires a lot of scientific research. And of course, there are many concerns about SRM, as there should be. It could have unintended consequences in terms of affecting weather patterns, which would then have consequent impacts on everything we have and everything we do in society, right? There's also concerns that SRM could be done quietly by some rogue actor or nation and maybe not regulated or controlled. And of course, as Mike said, there's the concern that SRM gets treated as kind of a get out of jail free card that would allow people not to reduce the incentive for lowering our emissions. On the other hand, with the current state of global mitigation efforts, temperatures are continuing to rise, as are the associated risks. And every increment of warming really matters because the impacts compound with increasing temperature. So there really is an increasing urgency to develop a comprehensive scientific understanding of SRM in order to inform any future decisions about whether, and if so, how to deploy these methods. So, as the nation's environmental intelligence agency, NOAA is the lead federal science entity investigating all aspects of Earth's climate system. We've developed world-class, unique observing and modeling capabilities, that will be crucial for understanding the feasibility, the efficacy, and the potential risks of SRM. In December 2019, so 5 years ago, Congress directed NOAA to expand its research to include understanding the processes that underlie these proposed SRM methods. And in response, we established the Earth's Radiation Budget Program. This program is a multi-year research effort to investigate, monitor, and assess natural, inadvertent, or intentional activity that would alter Earth's radiation budget by increasing the reflectivity of the atmosphere or of clouds, and to study the potential impacts on weather and climate. Our mandate includes SRM research, and we're the only congressionally mandated program in the federal government. As part of our guidance from Congress, our agency's also been asked to develop components of a monitoring infrastructure capable of detecting and attributing any large-scale attempts at SRM. What we're doing is we're understanding the physical science basis of SRM. We're trying to measure and monitor the atmosphere, as I said. We're trying to improve models that are our primary tool for simulating SRM. And we're studying a number of analogs for SRM, like volcanic eruptions and ship tracks. NOAA is also the legally mandated entity to which anyone attempting to carry out any activity on SRM must report. I want to emphasize that NOAA is not developing or testing SRM technologies. We're not advocating for or against SRM deployment. We're not conducting any experiments on SRM at any scale in the atmosphere. And we're not providing permits to anybody else who might try to do that. What I did want to say is a few words about some of the activities that we are engaged in. One of them is a network of small balloons. These are small weather balloons. We call it BSAP, which is Balloon Baseline Stratospheric Aerosol Profiles. And what we're doing is taking advantage of the homogeneity of the stratosphere and our extensive network of atmospheric observations. So by launching these small balloons with a sensor for aerosols on a regular basis, we can build up over time an average picture of what's going on in the stratosphere. And that work has two benefits. One is it gives us that baseline understanding of the stratosphere, and it allows us to see how natural events, as well as human activity, are changing that baseline. So we can use the measurements from this system to look for anomalies that shouldn't be there. And the more that we know about what the natural variability looks like, the more we're able to say, hey, that's not natural, or that looks really strange. And so if somebody did try to deliberately tamper with the Earth's atmosphere, this balloon program is at the core of our effort to attempt to detect it. Another aspect of our work is to characterize the state, in trying to characterize the state of the stratosphere, is our aircraft observing program. It's a set of field observations that we call SABRE, which is a long acronym that I won't tell you, but the goal here is to carry out a series of flights. We did our first set in early 2023, and we put a set of very sophisticated sensors on a high altitude aircraft, and we fly them in various regions of the stratosphere. In 2023, we flew in the very undersampled Arctic stratosphere, and we're building up a much better understanding of what produces all the aerosol particles and the trace gases that are already there in the stratosphere, whether it's from natural sources like the ocean or fires or volcanic eruptions, or is it from human activity? One of the very interesting findings from that study in 2023 was the finding that there were metals on a number of the stratospheric particles in the Arctic stratosphere, which match exactly the metals from vaporized space vehicles that were in low Earth orbit and that naturally fall back down to through the atmosphere. They burn up, and those metals then boil off and then recondense on particles. So we're finding out about something that's already happening and that's actually expanding over time, and that's the increasing amount of space vehicles being put into low Earth orbit. So these two programs together, these two observing programs together, represent NOAA's long-term investment in unparalleled stratospheric observing capabilities, and they're already paying big dividends. The other side of our work is to build models and to carry out research plans for SRM. So the observations I talked about are going to be very important for testing and improving our models. So if someone builds one of these very sophisticated numerical models and says, my model says we can geoengineer our way out of a climate crisis, our scientists will be able to ask, well, does your model really get the right answer? Does it reproduce these observations of the atmosphere right now? These models are important because they really are our best tools for predicting and projecting possible futures, including those that involve SRM. We're also, as I said, supporting work on research roadmaps, which are aimed at further building up this base of knowledge as we bring all of these aspects of the science together. And the ultimate goal is to be able to inform scientific assessment activities of whether proposed SRM approaches will have the desired impacts at reducing climate risks and allow evaluation of the unintended consequences of these methods.
Greg, I wonder how many slides you have left, just because we want to get to the next speaker. So sorry,
Yeah.
this is great, but
yeah. Okay, I want to say two more things. One thing is there's activity going on beyond NOAA, and there's a number of government-funded efforts as well as non-governmental organizations funded by philanthropies that are already carrying out research in various parts of the planet on SRM, including carrying out experiments in the actual atmosphere. And the other aspect of that work is that spending on that work is already outpacing what the US federal government is spending. And then the last thing I wanted to say was, I'll leave you with some kind of high-level bullets here. SRM is really moving very quickly from a theoretical possibility to a tool in the climate toolbox, and even a climate security issue. And so that's why the research now is so urgent. And again, I want to emphasize NOAA is not advocating for or against the use of SRM, but staying blind to whether it's feasible and what its impacts might be is not a useful stance either. So in a couple of decades, when somebody asks us, should we or should we not, or could we not carry out SRM, it would be very irresponsible if we had no answers for them. And it's really NOAA's responsibility to provide those answers. I left you with a couple of newspaper articles here that are really great if you want to know more about our program. And I'll stop talking, and I'm happy to answer questions after Suchi has a chance to speak.
Thank you, Dr. Frost.
Yes, and let me stop sharing. There you go.
All right. Our next speaker, Dr. Suchi Talati, is a climate technology governance expert and founder of the Alliance for Just Deliberation on Solar Geoengineering, DSG, a nonprofit organizing working towards just and inclusive deliberation about research and the potential use of solar geoengineering. Suchi, it's great to have you on here. Take it away.
Thanks so much, Quentin, and thanks so much to Quentin and Mike and CCAN for giving me the opportunity to chat with you all. So as Quentin mentioned, I launched a new nonprofit organization a little under 2 years ago called the Alliance for Just Deliberation on Solar Geoengineering, or DSG for short. DSG is an organization that's focused on the intersection of justice and governance dimensions of SRM. And we were really trying to think critically about how to empower climate vulnerable communities in decisions and deliberations. As our name suggests, we work on how to make things more inclusive and what justice really means in the context of SRM research and potential future use or non-use of SRM. Our overarching goal is not to advocate for the use or non-use of these technologies, but rather to help build different perspectives to emerge from the global south and from climate vulnerable communities around the world for those voices to be elevated in international discussions. As you've heard today, SRM is an emerging set of approaches that's becoming increasingly part of the climate response discussion as we see impacts worsen and we see existing policies continuously prove insufficient. It's a relatively simple technology in theory, but is in reality immensely complex when it comes to how it could be used, by whom, and to what end. So I wanted to share a little insight into kind of how I came to work on SRM and to highlight why it's so important to engage in this space. I've been working on climate change for the entirety of my academic and professional career. I did a PhD in engineering and public policy on climate change. I worked in the US Congress on adaptation and disaster recovery at different climate nonprofits, engaging on climate policy, And most recently, I worked in the Biden administration at the Department of Energy to lead governance work on carbon dioxide removal. All of these things, mitigation, adaptation, and CDR, are incredibly important to do and to grow in just and sustainable ways. But what really scares me is insufficient attention being paid to impacts and the people that are suffering them today. We've had huge climate wins in the United States with the Infrastructure Act and with the IRA, but even if we hit net zero tomorrow, impacts from climate change will continue for decades to come. We're not funding adaptation anywhere close to the levels necessary, and there are impacts that adaptation can't address. SRM is a technology that may have the potential to limit harm from some, though definitely not all, impacts from climate change. But if done poorly, without sufficient information, and not in alignment with the broader climate response portfolio, SRM could also exacerbate suffering and harm. And this challenge is why I decided to dedicate my career to working on SRM governance and justice. To ensure that we can have informed decisions, we really do need a lot more information about potential impacts of SRM. Things like public health, climate displacement, food security, extreme heat, and so many other things. Not building that understanding is another ethical failing in climate change. We also need well-governed research to develop that knowledge in a way that's democratic, inclusive, and open. In this vein, the critical question that DSG is engaging with is how research is being conducted. How are research questions being developed and by whom? Who's funding that research and where? Is research being responsive to the questions being asked by the most vulnerable communities that have the most to gain or lose from these types of decisions? So as we acknowledge the deep need for more research, I also want to name some specific challenges that the SRM field faces, especially as momentum around this topic is rapidly expanding across public, private, and media sectors. The ones listed here are by no means all-encompassing, but areas really worth emphasizing. So first and foremost, the field is currently extremely global north-centric. This is true on both ends of the advocacy spectrum, from those very opposed to SRM and to those who are more in favor of the technology. This is deeply problematic. Research and governance need a lot more participation and leadership in real and meaningful ways from the global south, rather than speaking for them. But there have been very few efforts to try and shift the dynamic. Second, there's extremely limited governance. We don't have formal governance on an international level across the entire R&D spectrum, which puts us in a very dangerous situation for how SRM could evolve. Third is that civil society is currently largely unengaged. NGOs have either been unable or unwilling to find pathways to engage in the space, which leaves it empty of necessary and constructive civil society voices. Civil society is so key to building policy and holding governments accountable. And without that involvement, the existing narratives are going to lead privileged and powerful actors to speak on behalf of what communities and countries really want. And lastly, the contentious nature of SRM is really driving unproductive discussion. It's really how the field is perceived, which makes it incredibly hard to build a legitimate discourse around governance and how research should proceed. So I want to distill kind of these overarching gaps and needs into three main areas, which are knowledge, engagement, and decision-making. We need foundational knowledge in SRM science and policy, and this is a major gap in the global north and the south. We need resources to make that happen. We also need a lot more engagement. We need participation across sectors at a range of scales to serve different purposes. This means things like co-developing research and policy priorities, making sure that people can participate in different types of decision-making processes, and that people can also advocate for their own preferences. And lastly, as I mentioned earlier, we don't have any decision-making frameworks for SRM. We have to build these structures that are capable of making binding rules and agreements for both research and deployment. All these gaps are really deeply linked to one another. The ability to achieve more just outcomes, public trust, and legitimacy is dependent on all three of these areas succeeding. And so overall, when we think about how to actually do this type of necessary work in governing and researching SRM, we have to ask the question around how these types of engagement measures could occur, by whom, and what political structures and institutions will SRM exist within. Ultimately, my motivation to work on SRM governance stems from climate justice. We have a responsibility to limit harm for the most climate vulnerable, and we have a responsibility to ensure that those most vulnerable communities are empowered to make decisions about their own lives. We cannot perpetuate the colonialism that still lives in climate governance so deeply today. So all of this led to the founding of DSG. Our organization is really focused on how we can operationalize a lot of the recommendations I just discussed. So far, we're in a few different countries and regions, and we hope to be in more places next year. But importantly, this is intentionally slow work because it's important to take time to build trust, to share information in unbiased ways, and to make sure that it can be sustained and meaningful. So as I mentioned, we do not advocate for use or non-use of these technologies, but rather to help build different perspectives emerge and for those voices to be elevated in future discussions. We're really focused on civil society organizations and policymakers through emphasizing local partnerships and leadership, again, being as unbiased as we can and making sure that that knowledge can then be used. And so to give a little bit of a sense of what that looks like, these are two pictures from workshops that we had at the end of 2024, one in South Africa, one in Pakistan. And this is just a list of kind of a high level list of the types of work that we do. We try to understand the landscape of actors and the history in different regions in the context of SRM, climate, technology, and politics. We go on the ground to meet with a range of stakeholders in civil society and policy communities to understand where they are. Do they want to learn about this? Is this interesting to them? How can we help? What resources can we provide? And to try and build collaborations and partnerships. Different people are going to need different things, and the mechanisms by which we can do work together are going to look different across different types of communities. We're trying to build a wide-ranging communications portfolio that can provide a platform to new actors to engage in this space. And we also want to work with journalists around the world. People perceive SRM based on what they read in media, and journalists need more information both about climate change and SRM to be able to write about the space with scientific integrity and with an understanding of how the space is evolving. And lastly, we actively contribute and engage with public and intergovernmental institutions like the UN, which are building a lot more processes over the last couple of years. And we hope to continue to see them engage to build more robust governance in ways that can be internationally participatory. So I will end there, and I'm more than happy to take questions in just a bit.
Fantastic. Suchi, thank you so much. Dr. Frost, thank you for your presentations. Quentin, and now we do have a few questions. We want to invite others. If you have questions, please put them in the chat and we will try to get to as many as we can. Perhaps we can go even past 8 p.m. since we're running a little bit over budget here. Suchi, one question that we have here is, while research is being done to try to gather more information on this topic, is there an international treaty banning geoengineering deployment? And if not, do we need one?
So there is not a treaty right now on SRM in any way. We saw some discussion on SRM in some international bodies, like the Convention on Biological Diversity, and most recently at the UN Environment Assembly. There was an agreement at the CBD in 2010 to be cautious around outdoor SRM experimentation and potential impacts, but did iterate also that SRM research was necessary and that we needed to do more on that topic. We've seen movement from countries across the global north and south have interest in figuring out what to do on SRM, from things like creating an expert report and assessment or creating a repository of information. And most recently, the EU in December suggested that a moratorium on SRM deployment might be a helpful way to build a framework for research to be more protected and for it to happen in ways that don't lead to potential deployment. So that's becoming an area of more interest. But as I mentioned, we have no international binding governance on SRM right now.
Thank you for that. Quentin, next question I'd like to direct to you, and that is, will the new Congress in DC just shut down all research like NOAA's?
Thank you, Mike, for that question. No, I think they would have a difficult time shutting down all research done by any of the agencies, including NOAA. And certainly we will be on the front lines of fighting that, along with Senator Chris Van Hollen, who represents Maryland and the state where NOAA is headquartered.
Great, fantastic. And Dr. Frost, can limited testing of geoengineering techniques like cloud brightening or sulfur injection be done safely in your view?
It's a great question. I think we're still not fully sure of that. There has been proposals, for example, by the National Academies to do things to limit the amount of material put into the atmosphere so that the impact would be a negligible amount. But again, we're depending on models to tell us that. And those models are still very uncertain. So I think the jury's still out, and that's part of the reason why we need to do the research we're doing before we start doing large scale testing in the atmosphere.
Great. And there was a question, and I'm looking for it here, that basically says, in order to truly test a geoengineering light reflection deployment, you'd have to actually do it. And
Yeah.
have we already not been reflecting sunlight through fossil fuel use? And does that lessen the concern that, I mean, have we already been doing it? And what did we learn from that?
Right. So as I mentioned, we have natural proxies like volcanic eruptions that tell us, yes, if you put aerosols in the stratosphere, it will cool things. We also have the inadvertent experiment of putting pollution aerosols in the lower atmosphere. And then as those were cleaned up in order to clean our air, we see that, in fact, the opposite can happen, right? We get some warming as a result because that pollution was actually reflecting a little bit of sunlight itself and scattering radiation. We can learn a lot. I believe we can learn a lot from doing the kinds of research that I talked about. I think the most important thing now is to really get good established baselines that will allow us to actually detect anomalies, changes when material is started to be introduced to the atmosphere. Unless we do that, unless we have those baselines, we don't really know. We won't be able to know if to be able to attribute the impacts after introduction material, right? How will we know if the changes that happen to weather and to climate are really because of the introduction of that material or for some other reason? The atmosphere, the Earth system, it's a complicated place. And that's why we're trying to make our models better, because we're putting a lot of faith in those models to tell us what's going to happen next.
Fantastic. I'm going to take the next question, which is, how have other climate nonprofits responded to CCAN's support of geoengineering research? I will tell you that we've just, really today become public in this advocacy, which, as Quentin described, has been an ongoing 1.5 year internal conversation between me and the board of directors, between the board of directors and the staff, between the staff and the leadership. We developed our statement of principles. We were very, very deliberative and intentional as we've gotten to this day where we're now sharing our views with the video you saw earlier in this webinar, our website, which has gone public today, which we invite you again to explore, frequently asked questions, link to Suchi Talati's work, to Dr. Frost's work at NOAA, learn more about this. But our reaction from groups that we have talked to prior to today in the climate advocacy and carbon mitigation world, the reaction has been one of thoughtfulness. We've only had really a handful of groups say even research is a bad idea. I think most people in the general public, journalists, nonprofit leaders, both at the regional, local, and national levels, realize that we are of truly dramatic warming. I mean, since June of 2023, every month has set a record for warming, many of them by record amounts. So we're setting records by record amounts. Last year, or in 2023, we got in 1 year the kind of warming prior to 2023 that we would expect over 10 years, and we got it in 1 year. So clearly, we've crossed some thresholds. There are some feedback loops going on that our science can't even fully explain. There's talk of maybe the El Nino last year was driving the warming, but that has been mostly ruled out by science. Maybe this a volcano in Tonga that spewed an enormous amount of water vapor into the stratosphere was accounting for the warming, and that's been ruled out. And in fact, it brought I contributed to reflecting more sunlight from the planet. So despite that volcanic eruption, we still had record warming. The jury's still a little bit out on the use of different ship-faring fuels by ships, but it certainly doesn't seem like this cleaner fuel, which is creating less cloud pollution, can possibly be responsible for the record dramatic new warming that we've seen since June of 2023. So most nonprofit leaders that we talk to, climate activists, recognize this runaway warming, are sympathetic to the natural, I think, prudence of wanting to research this more. And we expect that more groups will continue this conversation. Quentin, is there another question that looks good to you to ask?
Yeah, this question kind of came up in various different ways from a number of different people. What are the impacts of SRM on endangered species or agriculture or communities? And so one thing that I wanted to make sure that, and I'll let Dr. Frost also respond to this, is that CCAN's effort is not just to keep all of this research housed in NOAA. We're also going to be advocating to make sure that some of these research dollars go to the EPA, go to USDA, so they can look at various different, how does it impact agriculture? How does it, the social science, how it affects migration patterns with the State Department? So, right now, there's the congressional mandate for NOAA at $9.5 million a year. But CCAN's mission over the next few years is to build the political will so we can get more research dollars to all these various different agencies so they can use their expertise to look at how it impacts all these various different areas. So you didn't hear that tonight, but it is our mission to make sure that when we have this webinar a year from now, we can tell you that there's more research coming in all these different areas that we didn't really cover tonight. Dr. Frost.
Just quickly, I agree with what you said, Quentin. It's really those impacts on society and on ecosystems. Those are the most important. In order to know what those impacts are going to be, first we have to know how is weather and climate going to be impacted, because those other more complicated feedbacks respond to that, and we don't have a good handle even on the direct impacts on climate. So we need to understand that if we're going to really understand the follow-on effects. And yes, we'll need our partners to be engaged on this. NOAA can't do all of this by itself, although we do care deeply and we have a lot of resources to look at some of these questions, but not all of them.
And Sichi, I did want to ask you a question that we have gotten before. It's not a question that came up tonight, but we've been asked, CCAN has, in terms of international governance and inclusion of voices from the global South. And the question is, for example, the Pakistan floods that happened a couple of years ago, so many people affected by those floods, were not aware of the full details of climate change and climate change impacts on that level of extreme precipitation event. And if people, understandably, in impoverished countries, who many struggling just to get by day to day, aren't aware of climate change causing the natural disasters where they live, how do you then go to reflecting sunlight or just solar radiation modification conversations.
Yeah, I mean, I think it's part of our responsibility to help build capacity with all different kinds of organizations and to provide more information on climate change. And I think we've seen, if you look at Pakistan now, we've seen drastic shifts in how much the government and nonprofit organizations and universities are paying attention to climate change. And the research on climate change has grown exponentially. And I think what I have found is not to underestimate people. I think people have just massive capacity to learn. I think people are incredibly thirsty for information, and we shouldn't presume what people want to know or what they don't want to know. And I hope I see more efforts on trying to provide education and knowledge in ways that are unbiased as well. Because I think doing advocacy through education, I think is unethical in a lot of ways because people deserve to, have the opportunity to decide what they think and to build their own opinions.
And several versions of this question have been asked tonight, and that is why the focus on reflecting sunlight from the planet, having that conversation. Most of us here tonight in this webinar have acknowledged that carbon direct capture, removing carbon from the atmosphere, is a technology in its infancy. In fact, I've had one climate scientist at the University of Maryland say, climate removal technology is today where solar was in the 1970s. So why not just a crash course focus, mass investment in research to remove carbon from the atmosphere instead of sort of leapfrogging it to a focus on reflecting sunlight from the planet? Anybody want to take that on? Suchi?
Oh yeah, no, I think it's a great question. And I think for me, none of these things are mutually exclusive, right? Billions of dollars over the last few years are now being put into CDR, into federal research. We're seeing billions of dollars come from the private sector in funding kind of both research and entrepreneurial innovation. We've seen a lot of companies come up in the last few years on CDR, and it's incredibly important. I think we will need good CDR that results in climate benefits to hit our net zero targets. That is a fact. Whether you like whatever you think about CDR and its use and with the involvement of the fossil fuel industry, which I oppose, CDR will be needed. That doesn't change the fact that impacts will also be happening, right? And I think thinking about SRM as a replacement for any of these is not something that we want to do, right? We want to think about how SRM fits into that broader response portfolio and if it can be a stopgap, right? It may not be, right? And that's what research could also show. Research could show that SRM won't work and it's a bad idea. And if that's the case, we also need to know that because people deserve to be prepared and we need to fund adaptation at massive levels regardless. But I hope that could, also spur a really important conversation on the fact that we haven't been focusing on impacts including in the United States. All these really massive wins in climate policy haven't really focused on the adaptation needs of a lot of different vulnerable communities as well.
Fantastic. I've been given a warning that our webinar maximum limit might be happening.
No,
Nicole,
we're actually all good. Yeah, we can keep going, and whoever's able to stay on is welcome to continue to hear from our panelists.
well, we have some more questions. So if those of you who have joined us, there's still a lot of people on the webinar. We're going to take a few more questions. I did want to say that in my opening video, I did try to include my personal story and my neighborhood and the climate extremes that are happening right outside my door, and I think are happening in everyone's local communities. I have a book that's coming out in March from St. Martin's Press called The Lost Trees of Willow Avenue, a story of climate and hope on one American street, where I literally take a year, I keep a record of climate impacts on my street for a year. Lyme disease, flooding, trees dying, but also positives, a lot more solar and electric vehicles in my neighborhood. But I also veer into this conversation about solar geoengineering. So much of what I've talked about tonight is captured in the narrative of that book. I'll drop a link in the chat to that book, but it's called The Lost Trees of Willow Avenue. It'll be out in March. You can pre-order now at Amazon or wherever you buy books. Greg Frost, removing carbon from the air, carbon direct removal. Your thoughts from a NOAA perspective on that?
Right. I mean, I think I'd like to echo what or emphasize what Sushi said about that. I mean, the physics is kind of unforgiving. We're going to need to remove some of the carbon that's in the atmosphere now already if we're going to hit the temperature thresholds that we set for ourselves. Those techniques are all in their infancy, and it's not clear yet which of them will be viable to remove enough carbon in a way that doesn't have knockoff effects that are undesirable. I was part of a group of federal agencies that developed a research plan for marine carbon dioxide removal approaches. So again, directing the US government, how could it do the research necessary to inform future policy decisions? So again, it's the need for the research now to understand that. So I don't think my personal feeling, there's no way around doing some amount of carbon removal. The question is how to do it. And that's why I added it to the list of the climate toolbox. I think that it's part of the ultimate solution.
The question of Donald Trump has come up a couple of times. Quentin, you spend a lot of time on Capitol Hill. Do you, I know in 2020, the appropriations bill that actually funds NOAA and all the work that Dr. Frost and Dr. Breeze do was actually passed by a bipartisan Congress and signed into law by Donald Trump. Do you see the possibility of bipartisan support with Donald Trump supporting an expansion of the kind of research and all of government involvement in this?
Yeah, great question. I know that there are a lot of concerns about, will NOAA even exist because of Project 2025? We know that it's in the document. They said that they want to get rid of it, but to actually get rid of the agency is far more difficult than that document laid out. So we're fairly confident that NOAA will be fine and safe, and that the research dollars will be there. Like Mike mentioned, it was done in a bipartisan way. There are a lot of interest of this research, especially from Republican senators from like the Arctic, so Alaska, so Murkowski, and others. And so we've been engaging in some conversations already with the members on the Senate side on the Appropriations Committee who have shown some interest. And so we feel fairly confident that, we can move this forward. And quite honestly, this research conversation hasn't really boiled up to the top of the sort of partisan political conversations that we've seen nationally. So essentially, this research is below the radar. And so it's staying that way right now. And we feel, again, confident that the agencies will be protected and we'll be able to find enough senators who care about this. And it's on our job as advocates to make sure that the senators and members of Congress care about this to move these dollars forward.
Fantastic. And, I think we're going to leave it there. I feel like we gave y'all a good 30 minutes of Q&A. Again, check out our website. The link is in the chat. You can go to chesapeakeclimate.org. I want to thank Dr. Greg Frost for taking time out of his evening with incredible clarity and specificity to teach us some about what NOAA is doing on this issue. Suchi Talati, thank you for your advocacy. You've been working at this for a long time. You've been a leader on this. You're an inspiration to all of us at CCAN, and we were glad to bring your voice to so many of our members across the country tonight. Quentin Scott, Federal Director of Chesapeake Climate Action Network, thank you. I want to thank Nicole Schroyer, our comms person behind the scenes, who pulled all the buttons and took care of all the tech tonight. Victoria Breeze, thank you for being on the bench in case we could bring you in. And on behalf of CCAN, our board of directors, our staff, we hope that you'll stay engaged on this. Please stay in touch with us. Follow up with any additional questions through the website. We will be sending you from time to time email alerts, and we hope to continue to explore this conversation with you in the months and years ahead. So thank you, everyone, and have a great evening.